This video is brought to you by MathGalaxy.com. This is our whole numbers program, which covers these topics. And in this video, we'll be doing whole number word problems. In one-step word problems, the choices are add, subtract, multiply, or divide. Addition and subtraction are the easiest. And in addition and subtraction, there's just one name that goes with the numbers. So in this case, it's cakes. For example, if you made 8 cakes yesterday and 12 today, how many did you make in all? 8 yesterday, 12 today, so that's 20 in all. For addition, some of the keywords are how much, how many, altogether, in all, sum, total. For subtraction, some of the keywords are what is the difference, how much more, how much less, how much further, how much longer, shorter, etc. The ER and comparative words. For example, if one can weighs 18 ounces and another can weighs 12 ounces, how much more does the first can weigh? Again, a clue that it's either addition or subtraction is that there's just one name. Ounces with 18 and ounces with 12. So how much more when it's in the question part is generally subtraction. So 1 is 18, 1 is 12. How much more is this? It's 6. 18 minus 12. One case where you have to be careful, though, is if the comparative word is in the information part and not in the question. For example, here, Alice has $12, Bob has $8 more. How many dollars does Bob have? So we start with Alice has 12 and Bob has $8 more. So Bob has $20. So if the comparative word is in the question, it's subtraction. If it's in the information part, it may not be subtraction, and you have to read the problem carefully in that case, and also drawing diagrams may help. With addition and subtraction, the names that go with the numbers are the same or in the same category. You're adding apples to apples, inches to inches, or subtracting inches from inches. Or in the same category, 2 apples plus 3 bananas equals 5 pieces of fruit. Multiplication and division are the hardest to distinguish, but in those problems there are 2 names. For example, here if one can weighs 12 pounds, how much will 5 cans weigh? So you have 2 names, cans and pounds. So in those cases there are 3 numbers. The number of things, the value for one thing, and the total for all of them. So if you're given the value for one thing and the number of things, it's a multiplication problem. 12 pounds for 1 can times 5 cans gives you a total of 60 pounds. There are 2 types of division problems. This one is the inverse of a multiplication problem. Here, if you have 60 pounds of dirt to put into 5 buckets, how many pounds per bucket is that? So a multiplication problem is when you're given a value for one thing and asked for the total for more than one. Here you're given the total for more than one and asked to find the value for one of them. So that's a division problem. So here you have 60 pounds for 5 things. So for one of them, 60 divided by 5 is 12. And one way to analyze the problem is to set it up in a multiplication format. You have the value for one thing times the number of things is equal to the total, and see which of those you have numbers for. So 60 pounds here is the total, and 5 buckets is the number of things. So that tells you you're looking for this multiplier, the value for one thing. This is the second type of division problem. If you have 60 pounds of dirt and a bucket that can hold 12 pounds, how many trips will you need to move the dirt? So setting it up in the multiplication format, we have the value for one thing, the number of things, and the total for all of them. And then you want to place the numbers where they belong. So again, 60 is the total, and the two names here are buckets and pounds. So one bucket, 12 pounds. So that's the value for one thing. So that tells you you're looking for the number of things. How many times you have to repeat this 12. Sort of one trip with the bucket, second, third, fourth, fifth, to get to the total. So that's a division problem with the total divided by the value for one thing. So in both types of division problems, you'll be given the total. In multi-step problems, you may have to solve some preliminary steps. For example, here you may have been told that you had 3 piles of 20 pounds each. This is an example of a multi-step word problem. You need to ship 300 crayons in boxes of 20. If each box weighs 14 pounds, what is the total weight of the boxes? Well, if you think about what you finally want, total weight, you need the weight per one box and the number of boxes to get the total. So we have the weight for one box, so that's the value for one thing. So now we need the number of boxes. So that will become a subproblem. And here it's somewhat obvious. It's 300 divided by 20 or 15. But if you wanted to analyze it, again, you could set it up as 20 crayons in a box times the number of boxes has to account for 300 crayons. So setting up in the multiplication format, it tells us we need 15 boxes. So the subproblem gives us the information we need for that, and then we multiply. It tells us the total weight is 210 pounds. Setting up a diagram can also help. 20 crayons per box, and 15 times that will pack the 300 crayons, and each of those 15 is 14 pounds. This is another example of a multi-step word problem. Last year, 256 students attended your school. This year, 67 more attended. If a bus carries 25 students, how many buses does your school need? Well, it looks like it may be multiplication or division because we have two names, students and buses. So what information do we have? Well, a bus carries 25 students. So that's the value for one thing. So we have 25 students in one bus. Then times the number of buses will tell us how many students we can transport. And the number we have to transport here is the total number of students. And that becomes a subproblem. 256 students last year, 67 more this year. So this year we have a total of 323 students that we have to transport. So that's a division problem. 323 divided by 25 is 12 with a remainder of 23. But you always have to analyze the word problem in terms of the real-world situation. 12 buses won't be enough. We need an extra bus to handle the extra 23. So the answer is 13 buses. If you want more practice problems, you can go to MathGalaxy.com. The program has two modes. One talks you through problems step by step. The other just asks for a final answer. And when you exit the final answer mode, it gives you a score, which you can also print and get a certificate. And as you do problems, you earn robots, which you can use in a maze game called the Labyrinth. There are 3 levels corresponding to different board sizes. So this is an example of one of the mazes. The screen looks compressed vertically because of the difference in screen sizes between the game and the video, but in the game it isn't compressed. So, for example, here you have to move, get the treasure, and get out safely. Okay, an example of another maze where you have to decide on a path and avoid the creatures. Another type maze. And they're created randomly, so everyone will be different. So, and some of these creatures are smart, some aren't. So another type. So those have been some examples of the mazes. There's also a riddles game like Wheel of Fortune, where the answers to math problems help you solve a riddle. And you can do these topics, for example, time. There are up to 3 players. So here the riddle is, where does sour cream come from? And at the beginning or end of your turn, you can choose to solve the riddle, or you could try to guess letters. So E is 10:05, so E goes there, and let's pass, and let's say you wanted to get O, which is 4:35. Okay, let's try to solve this. So discontented cows. Let's see if that works. Okay, so it does. And measurement, you can do any of these. For example, multiplying length. So how do you make an elephant float? So let's say like E, 1 foot, 2 inches, 6 times. So that gives you 6 feet and another 12 inches, so 7 feet, no inches. So after a few more letters, it looks like we're ready to solve this. So with root beer and an elephant. Okay, so that works. And you can also do money and 1 or 2 digit hulls for all of the operations. And the word jumbles game is like the riddles, except you're solving word jumbles rather than riddles. There's also a game called Bridge the Swamp, where you can practice these operations. For example, multiplication. There are 3 board sizes. Red is trying to build a bridge in this direction. Green is trying to build a bridge in this direction. And the first player to complete a bridge and block the other player wins. There are no wrong answers, but knowing the operations gives you a better chance of picking the block that you want. For example, green goes first if green wanted 20, so that would be 4 times 5. And if red wanted to block with 35, that would be 5 times 7. So that's a review of the games that come with the program. This has been a review of whole number word problems. If you want more review and practice, you can go to MathGalaxy.com. Thank you for listening.